Here's example number 4 from 5.3. I want you to explore it a little bit with me. We've been talking about the two pieces of the fundamental theorem of calculus, and we just discussed in the last couple videos that the derivative of the antiderivative are just inverse functions of each other, and they should cancel each other out. But if you remember from the last few examples, we always went from 0 to x, or from pi over 4 to x, but this example looks a little bit different. It goes from pi over 2 to x cubed, and we need to decide if that's going to make a difference. And so let's go ahead and do this the long way and see if we can find a shortcut that still works. Because this question is asking us to find the derivative of this antiderivative, right? And so we need to be able to recognize that those are inverse functions of each other, and they should just, quote unquote, cancel each other out, right? Let's do it the long way and see what happens though. And so if I ask you to take the antiderivative of cosine. The antiderivative of cosine is sine, and we're going to evaluate it from pi over 2 to x cubed. So using our first part of our fundamental theorem of calculus, we should be able to plug in our upper limit minus our lower limit, and I end up getting a sine of x cubed minus what's sine of pi over 2? 1. So I end up getting sine of x cubed minus 1. So that's my antiderivative. Now I want you to take its derivative. So it looks like this is a little bit of a chain rule, remember? And so the derivative of sine of x cubed should be the derivative of the outside. Keep your inside the same, and then don't forget to multiply by the derivative of your inside. You should get cosine, keep your inside the same, x cubed, but then don't forget your chain rule piece where you take the derivative of your inside, which is 3x squared. Remember, the derivative of 1 is just 0, so you should end up just getting 3x squared times the cosine of x cubed. Now, is that what we started off with? Ooh, that looks a little bit different, right? When before, we were able to just take this and say that my answer was going to be cosine of x, exchanging the t for an x. But in this case, it looks a little bit different. We didn't just replace it with an x. What does it look like it's replaced with? Well, to me, it looks like it's replaced with that upper limit. Is that the same as the other problems that we did? On all of these other examples, was our t replaced with our upper limit? Was our t replaced with our upper limit? Was our t's replaced with our upper limit? It looks like it, right? And so we just took all the problems that were from a number to x, and we just plugged in an x. So it looks like that would work here, where we could take out the t, we can plug in the x cubed instead. Oh, but wait a second. Isn't there this extra piece? So how do you think I can go from my original problem to my final answer without having to do any of this work? Well, if you can recognize that the derivative of the antiderivative are inverse functions of each other, they're going to cancel each other out. The only thing that should change is that this variable t should be replaced with that upper limit, so we end up with cosine of x cubed. But because it's more than just an x, we have to kind of think of that chain rule piece, and we have to make sure that we multiply it by the derivative of that inside. That works all the time. Go back and look at the other examples. If you go back and look at the other examples, maybe I can clear this off here. Clear page. If we can recognize in all of these examples that the derivative and the antiderivative are just going to cancel each other out, then we should be able to take this upper limit, plug it in, and then multiply by the derivative of that upper limit. So what's the derivative of x? Just 1, right? And so that's why I end up with 3x without having to do all of that work. Same idea with part B. I can plug in my x's wherever I see that variable, and then make sure I multiply by the derivative of that upper limit, which is just 1. And so that's my final answer without having to do all of that work. As long as it goes from a number up to a variable, x or x to the nth, then you should be able, and you're taking the derivative of that, right? The derivative of the antiderivative. You should be able to plug in this upper limit wherever you see the variable, and then multiply by the derivative of that upper limit. Okay? So that's kind of what we did here without having to do all of that work. Okay? I'm going to go ahead and skip 5 for now. We'll come back to it in the next video, but I want you to practice 6 now. Now that we've done one that looks like example number 4, If I give you this problem on a test and said that big F is the antiderivative, but I want you to take the derivative of the antiderivative, what would you get? Well, this is a chain rule integration, and we know that there is no such thing as chain rules, so you better know another way of doing it without doing it the long way. If you can recognize that the derivative of the antiderivative are just inverse functions of each other, and we're going from a number up to a variable, then we should be able to use that fundamental theorem of calculus, that second piece, that says that we can plug in that upper limit wherever we see that original variable, but then we have to make sure that we multiply by the derivative of that upper limit, which should be 2x. So we could say that the derivative of this antiderivative is 2x times the sine of x to the fourth, without having to do all of that work.